Communications technicians are required to work near commercial power sources that can reach levels of hundreds of kilovolts. All of us know that these voltage levels are extremely hazardous and that we must avoid contact with any of them. Lower voltages can be just as or more dangerous because we are exposed to them more often and do not respect what they can do to us. The safety of our employees is and always has been an extremely high priority. Today, you will be shown the Foreign Voltage Detector, or FVD, that is recommended by Time Warner Cable. With the Foreign Voltage Detector, or FVD, contact is not required. It needs only to be in close proximity to the source. Detection through painted surfaces, even wire insulation, is now an easy task. Let's take a closer look at the FVD. The FVD has only one operating control, the power switch, which is located under the decal on the FVD face. You'll notice that it's marked by a large black dot. To turn the FVD on, you simply press and hold the power switch. The FVD turns off automatically when you release the switch. There are 3 indicators on the FVD. Near the probe end is a 10-step bar graph that indicates the amount of AC voltage being detected. The FVD does not detect or measure DC voltage. Please keep in mind that this is not intended to be a precision measuring device. Its precision is limited by the resolutions within the steps, as well as the distance between the probe and the source, and the physical size of the source conductor. When all 10 bars are illuminated, the voltage detected by the FVD is greater than 200 volts AC. The FVD is calibrated with the probe in contact with an insulated 22-gauge pair that is energized. When the 6th step of the bar graph is activated, 50 volts of AC have been detected. Along with the 6th bar graph step, another indicator, an audible alarm, will also be activated. The audible alarm will remain active as long as more than 50 volts AC are detected. The remaining indicator is a green LED located just below the bar graph window. This LED doubles as a power on indicator and a battery condition indicator. With a good battery, the LED will remain illuminated anytime the power switch is depressed. If the green LED does not illuminate, the battery must be replaced before use. To change the battery, you first locate the small slot in the battery cover on the back side of the FVD. Using a small screwdriver, simply pry the cover out. Replace the battery with a good quality 9-volt alkaline type. Replace the cover, and we are again ready to test. Test the FVD on a known AC voltage source when you receive it, then once a month thereafter. To begin testing with the FVD, turn it on a few feet away from the suspected source. When all of the bar graph steps deactivate and the LED illuminates, point the probe toward the suspected source and slowly move toward it. Remember that any time the audible alarm sounds, it means that the source is greater than 50 volts. Continue toward the suspected source until the alarm sounds or the probe touches the source. If no alarm has sounded by the time the probe touches the source, you know the source is less than 50 volts. If hazardous voltage is detected, you must proceed according to Time Warner Cable's safety practice. The FVD can detect AC voltage only. You must always look for indications of high current, such as discoloration, excessive heat, sagging drop, smoke, etc. Here are examples of a high current, low voltage condition as shown by the smoking NID and the melted coax outer sheath. Because the shield of the coax is grounded, the actual voltage on the shield is low until the cable is disconnected from the tap. Always follow Time Warner Cable safety practices when placing or removing temporary or permanent bonds. Let's take a look at a few practical applications where the FVD should be used. As a technician approaches a customer's property for a new install with existing cable service or a maintenance call, the FVD should be used to verify that the work area is clear of any foreign voltages. To accomplish this task, activate the FVD and verify that it passes the self-test and the battery is good. Then test any metallic or conductive material within your work area, such as a mobile home, the cable box, NID, power meter and conduits, ground wires, and interior or exterior breaker panel. The work area can be an electrical or mechanical room, an attic, a crawl space, a basement, a closet, an entertainment center, etc. All potential grounds must be verified that they have no foreign voltage before contact is made. Once you determine that there is no foreign voltage in your work area, you may continue to service the customer. It should be noted that any facility such as this mobile home, a metal building, metal conduit, virtually any conductive surface that should be grounded should not read any AC voltage. If any AC voltage is detected, the grounding of the facility should be suspect. This mobile home has been purposely energized, as could happen in the case of a power fault within the structure. When we test this conduit with the FVD, it appears to be energized. Now, watch what happens when the conduit is grounded. Note that no power is detected. In this case, the conduit was energized by the power inside until it was grounded. This energy was coupled to the conduit through the capacitance between the conduit and the power conductors. As you saw, the grounded conduit effectively shielded the power from being detected. It is important to understand that shielded power conductors cannot be detected by the FVD. Because the FVD is a remote sensing device, there are some testing situations that will produce different results. These situations require procedures that may be new to you. Users themselves may become energized due to capacitive coupling from the electric field, commonly referred to as the E field. A good example of this is in the vicinity of power transmission lines or under power distribution lines. This may cause the FVD to indicate a hazardous condition when it does not exist. This is demonstrated by standing under 230 kilovolt lines with the FVD indicating hazardous voltage. These power lines produce an E field. It surrounds the wires and can encompass large areas. The E field between the power line and nearby conductive objects causes these indications. Ungrounded objects within this E field will accumulate a voltage charge with very little current. The closer the ungrounded objects are located near earth ground, the lower the voltage charge. Because the user of the FVD is within the same E field, he can also become energized. These are not false indications. The indicated voltage does exist on the ungrounded object. To determine if this condition is actually causing a hazardous voltage indication, the user of the FVD should provide a temporary path to ground for his body in order to remove the voltage caused by capacitive coupling to the power line. The user then conducts another test. The recommended method for grounding the operator is for the operator to hold one end of a ground cord that is connected to an earth ground, a screwdriver inserted into the earth and connected to a ground cord. Do not use the vertical number 6 power ground on the pole. Notice when the operator grounds himself, the object ceases to indicate a hazard. When the ground cord is released, the voltage is again detected. If the hazardous voltage indication disappears, the user was energized and must continue to keep himself grounded while testing with the FVD. If the hazardous voltage indication persists after the user is grounded with the grounding cord, then the object should be considered hazardous. When testing a device that is cyclic in nature, such as a traffic light support strand, heat pump, air conditioning unit, air compressor, refrigerator, etc., the operator should always test through at least one complete cycle. This will avoid missing detection of a fault that occurs on a single phase of the cycle. The FVD can be used in any situation where a conductor could be energized. Here are some common situations where an FVD could be used in our industry, but these are not all of the situations. Strand, risers, down guys, power supplies, vertical ground wires and other grounds, house boxes, NIDs, amps or fiber nodes, the head end, towers. These are just a few of the situations you may encounter where you need to use the FVD. If in doubt, test. In summary, the FVD has been designed to overcome many of the limitations of previous test sets. The small size and ease of operation make it a very useful tool. However, no tool can be of any value if it's not used. Keep the FVD with you and use it at every opportunity you have.